Tonight, as your thoughts start to slow, let's drift gently into the cosmos and explore one of the universe's most fascinating and mysterious objects, neutron stars. Neutron stars are the remnants of massive stars that have ended their lives in spectacular explosions called supernovae. These stars are incredibly dense, small in size, yet contain more mass than our Sun. To give you a sense of scale, imagine taking a sugar cube-sized piece of a neutron star. It would weigh as much as a mountain. Stars, as you know, live for millions or billions of years. They shine because of nuclear fusion in their cores, burning hydrogen into helium and producing light and heat. But when a massive star exhausts its fuel, the outward pressure that balances gravity disappears. The core collapses, and in a dramatic cosmic finale, the star explodes as a supernova. What remains is a tiny, incredibly dense object, a neutron star. The name comes from the fact that these stars are mostly made of neutrons, subatomic particles that have no electric charge and form the dense core of atoms. In a neutron star, matter is compressed so tightly that atoms are crushed, electrons and protons combine, and what remains is a star composed almost entirely of neutrons. Neutron stars are small but extreme. Their diameter is only about 20 kilometers on average, yet their mass can be up to twice that of the Sun. This means that a sugar cube of neutron star material on Earth would weigh billions of tons. The gravity at the surface is immense. A person standing there would be flattened instantly. But there's more to their strangeness than just gravity. Neutron stars spin incredibly fast. Some rotate several times per second, while others spin hundreds of times in a single second. These rapidly spinning neutron stars are called pulsars, and they emit beams of electromagnetic radiation from their magnetic poles. As the star spins, these beams sweep across the cosmos like a lighthouse. And if Earth happens to lie in the path of the beam, we detect it as a pulse of light or radio waves. Imagine this: a star only 20 kilometers across, spinning hundreds of times per second, emitting energy with every rotation, a cosmic clockwork of unfathomable precision. Neutron stars are also incredibly magnetic. Some have magnetic fields 1 trillion times stronger than Earth's. These are called magnetars, and their magnetic power is so extreme that they can distort atoms and affect objects even far away. Magnetars occasionally release sudden bursts of energy, creating cosmic flares detectable across vast distances. Inside a neutron star, matter behaves in ways we can hardly imagine. The core may contain exotic particles, superfluid neutrons, or even quark matter. Our current understanding of physics is pushed to its limits. When trying to describe conditions inside these stars, each discovery about neutron stars brings more questions than answers, revealing just how mysterious the universe truly is. Neutron stars can also exist in binary systems, paired with other stars or even another neutron star. When two neutron stars orbit each other, they gradually spiral together due to gravitational waves, ripples in the fabric of space-time predicted by Einstein and observed only recently. When they finally collide, they produce a brilliant explosion called a kilonova. Releasing heavy elements like gold and platinum into the universe. In other words, some of the most precious materials on Earth were forged in the collisions of neutron stars billions of years ago. Let's take a moment to imagine the environment near a neutron star. The surface gravity is so intense that if you dropped a marshmallow, it would be crushed instantly, and the atoms would be stripped apart. Yet, in this extreme, delicate structures can still form, and their behavior teaches physicists about the fundamental forces of nature. The light we see from neutron stars may be faint or dazzling, depending on distance and type. Some are bright X-ray sources, heated by material falling onto them from a companion star. Others pulse gently in radio frequencies, marking time across the galaxy with perfect regularity. Neutron stars remind us of the incredible diversity of the universe. From our safe vantage point on Earth, they are tiny pinpricks of light, yet they embody extreme physics, unimaginable density, and powerful magnetic and gravitational forces. As you lie in bed tonight, picture a neutron star spinning silently, its beams sweeping across the cosmos, its magnetic fields bending the space around it, and matter crushed to densities that defy comprehension. This calm, precise dance continues, far beyond the reach of our eyes or hands, a cosmic heartbeat echoing across the galaxy. Neutron stars also give us a glimpse into time itself. Near them, time stretches due to gravity, a phenomenon called gravitational time dilation. If you were near a neutron star, seconds could feel like minutes or hours compared to Earth. It's a reminder that the universe is stranger than we can imagine, and that time and space are not absolute but flexible, shaped by the gravity of these dense, spinning remnants. Even in their calm, neutron stars are the aftermath of violent stellar deaths. They are both relics and creators, destroyers of their former star and forgers of the heaviest elements in the universe. Each neutron star is a testament to the balance of forces: gravity, nuclear pressure, electromagnetism, and rotation, all interacting to create something incredibly small, incredibly dense, and yet remarkably stable. Some neutron stars live alone, quietly drifting through the galaxy. Others are part of binary systems, locked in an eternal orbit. Some spin rapidly, pulsing like cosmic lighthouses. Some magnetars flare unpredictably, emitting bursts of energy that can travel millions of light years. The study of neutron stars has taught humanity many lessons. The laws of physics stretch to extremes. Gravity can dominate in ways we cannot replicate on Earth. Even the smallest objects can contain unimaginable energy. And the universe is far stranger and more beautiful than our daily lives suggest. As your eyelids grow heavy, imagine the stillness of space, interrupted only by the gentle spin of neutron stars, their faint light reaching across billions of kilometers, whispering the stories of collapsed stars and cosmic collisions. Tonight, let your mind drift with the stars. Let the universe's calm, extreme precision lull you towards sleep. Picture a neutron star spinning silently, its beams sweeping across the darkness, its core filled with neutrons densely packed beyond comprehension. Imagine the history of the universe contained in these stars, the explosions that created them, the collisions that forged gold and platinum, the quiet dance of binary systems spiraling together, all unfolding far beyond our sight, yet perfectly ordered. The universe is vast, mysterious, and calm. Neutron stars are among its quietest storytellers, showing us that even in destruction, there is order, and even in extreme density, there is beauty. Good night.